So concurrent execution means transaction processing permit multiple transaction to run concurrently, as well as multiple transaction to update data concurrently. Means we allow into the system that the transaction could run, two or more transaction could run concurrently, means at the same time simultaneously they will execute, as well as will allow them that the transaction will update the data concurrently, means they will update the data that is also simultaneously. So what it will cause, so we have to look for different complications related to consistency of the data consistency should maintain. That is the major look after for concurrency control. And why we allowing actually concurrency? So because it is creating the problem. See, when two or more transaction is updating one data, definitely there will be a problem. So why actually we are allowing them? So the reason behind that is to improve throughput of transactions and system resource utilization. We want to increase the throughput. Increase the throughput means we want that if we have the resources, so with the help of those resources, we utilize those resources in such a way so that we can improve the efficiency of the system. Means number of transaction or number of operation that will be allowed in the database would increase. If we do that, definitely my system will become more interactive. Many of the people will use my system and it will be globally accepted. So because of those reason, any management system, if you talk about mail, if you will talk about social media, if you'll talk about the e-commerce site, if you'll talk about the e-ticket booking site, so all those are different examples related to this concurrent execution. And all those application require that my system will be globally accepted and everybody come into my system for their use. The second thing, we can reduce the waiting time of the transaction. So if we allow only one process at a time in a single user concept, so definitely there will be a problem of waiting time. So one has to wait for a longer period of time, right? And when we are talking about multiple user will execute, or multiple user can enter into the system and do the database modifications. So here the waiting time will be reduced. So everybody at any time open the Gmail. Anybody anytime can open the Facebook. If let's say Facebook allow, let's say 100 million people or 100 people at a time, so what will happen? So only those people, if they will log out, then other people will be get entered into the system. So it will be a very you can say non-interactive site, and waiting time also is increasing. So we have to reduce the response time so that we can satisfy the customer need. Now what are the possible problem that may come when we are doing concurrent accessing or concurrent updation of the data into the database? So there are mainly three problems that may come. First is called lost update problem. Second is called inconsistent read problem. And the third one is called dirty read problem. Let's see one by one all those problems. So the first one is the lost update problem. Now the lost update itself says that if some transaction is updating the data into the database, so that updation may be lost. Why it may be lost? There is a scenario. When two concurrent transactions attempt to modify the same data item, an update made by one transaction Ti on data item X is lost due to the update made by another transaction T2 on data item X. So if T1 and T2 both are updating X, let's say T1 has updated X first, but T2 will update the X with its own data. So what will happen? The update done by T1 will be lost. So these may be the scenario that is called lost update problem. The second is called inconsistent read problem. When one transaction has to modify the data item X and at the same time, at the same data item is to read by some other transaction, then it is called inconsistent read problem. It means, let's say somebody has some transaction has modified the data and another transaction is reading the data, but it has to read the original data, not the modified data. At that particular time, there is the problem of inconsistent read. This means I have read the data which which I suppose not to read it. The reason is, let's say there is transaction one which is executing its operation, doing the right operation. Then what will happen? When the right operation will be done, the value of X will be changed. And after that, let's say T1 will be failed. So there is no commit, there is only partial commit. At but that particular time, transaction T1 fails. And just before that, transaction T2 has read the data which is modified by T1. So it is an inconsistent read, right? Because T1 has not done its operation fully. So anyway, it has to be rolled back and abort. But T2 has read the data which is which is actually the inconsistent data, which is not the actual data that T2 has to read. So that problem is called inconsistent read problem. Then there is a dirty read problem. When one transaction T1 update a data item X and then it fails, since the value of X will be rolled back to its original value, but in the meantime, another transaction T2 has read the value of X before it can roll back. The value of X read T2 is called dirty read, since it is the value created by transaction that has aborted. This problem is called dirty read problem. Now, there is the difference between inconsistent read and dirty read. Dirty read says that which I told you about the inconsistent read. So if T1 is there, T1 has updated the data, but after that it fails. So T2 will read that particular updated data. So that is called dirty read. What happened into inconsistent read? There is the transaction which is supposed to modify the data of X, but we haven't done the changes into the database, and another data is taking the data from directly from the database, not the modified database. Then it is called inconsistent read. Here in the inconsistent read, there is no failure of data, but the thing is that and a transaction has to read the updated data, but it has not read the updated data. That happen in the inconsistent read. But in the dirty read, some transaction has done the modification and then fail, and at that particular time another transaction has read that particular data, but afterwards there is a abort operation in which we have to roll back all the operation done by the transaction T1. It means we have to put the data which is the previous data of X, not the updated data by T1. So T2 has, what T2 will do is T2 has read the data which it doesn't has to means doesn't support supposed to read it. That is called dirty read. Let's see with the help of example all those problems one by one. The first is the lost update problem. Let's assume that these are the two transaction T1 and transaction T2. You can see both the transactions are updating the same data A, same data A. Now what happened in the concurrent concurrent execution of the transaction. Let's assume that this is T1. Let's assume that this is T2. When we do concurrent execution of the transaction, so generally what happen, some operation of T1 will perform. After that, some operation of T2 will perform. Again, some operation of T1 will perform. Again, some operation of T2 will perform. Again, some operation of T1 will perform. Again, some operation of T2 will perform. This is called non-serial execution, or you can say concurrent execution. So when we execute simultaneously, what will happen? Some of the operation of one transaction will execute, then some of the operation of another transaction will execute. Let's assume that some read operation has been done, and here again some read operation has been done by T1. Then this modification operation has been done, means A has been modified with some 5,000. Here some modification has been done with some 10,000. Now here some modification has been, means some operation has been executing. Here some operation has been executed. In that way, actually your execution take place in the concurrent system, which we are talking about. Okay. So some of the operation of this may be inside some of the operation of this. Are you getting it? What I'm saying? So it is not a serial scheduling in which all the operation of T1 will execute, then all the operation will T2 execute. That is called serial. Okay. And we have to do it parallel. It means concurrent. Concurrent execution is there. So let's assume that this type of transaction has been done. It means T1 will execute two of its operation, then T2 will execute one of its operation, then T1 will execute the rest of its operation, then T2 will execute the rest of its operation. Okay. It is happening in a concurrent system. Now, let's assume that the value of A is 3000. So this is the database state before the transaction starts, right? Okay. Now, when we'll start the execution, so which will start? This read will start. Now read is reading A. It means what I am reading? I am reading, how much I am reading? I am reading 3000. Okay, that is correct. Yes, it is correct. Now after that, what I am doing is I am updating the value of A in the buffer. So what is the value of A right now? 3000 plus 5000, it will be 8000. Correct? Now, after that, there is a read operation again. After that, there is a read operation again. So what is the value of A right now? It is 8000, right? It is 8000. Now, after that, there is a read operation on A. Now, what happened here? A will read from here or it will read from here. So definitely it will read from here because here there is no modification has been done. So if there is a read, means there is a fresh read, it will be read from the database. So this is the database right now, 3000. But T1 has updated the value of A, but not reflected into A. That is called, so what will happen? The updation of T1, you can see here, A is coming, right? Okay. This A will be 3000. Now write operation will be done. When we do write operation, the A value will be changed to how much? 8000, right? So the A value has been changed to 8000. Now you assume that this is now 8000 because I have done the write operation. Now there is a equal to A plus 1000. What is A right now? For how much A has been read? It is 3000 plus 10,000. It will be 13,000. Now there is a write operation. Write operation will be done. Then this value will be 13,000. Now what happened here? In this scenario, what happened? The update done by T1 is lost. What is the update? Update should be 8000. So if I'll execute in a normal way so that there will be no inconsistency. So for that, what we have to do? For that, what we have to do? Now here if you'll see, here if you'll see, 3000 has been read, A has been updated, and then there is a write operation, right? So if we'll make it as a serial one, means T1 will execute first and then T2 will execute, then what will happen? There will be no problem at all. T1 will execute it all its operation, means up to write. So this value will be 8000, right? Now after that T2 will perform, means it will do a read operation, then it will read how much? 8000, not 3000, because now it is updated. Now 8000 plus 10,000, it will become 18,000. So now it will become 18,000. 18,000 is the correct answer. Are you getting it? What I'm saying? So here, because of this concurrent execution, the update done by T1 has been lost, and my value is 13,000 instead of 18,000. So this 5,000 will be added into 3,000. It will be 8,000. Then again 10,000 will be added into that particular 8,000. It will be 18,000. It is a normal thinking or normal common sense how we can get the data. But here what I am getting 13,000 instead of 18,000. So the update done by this transaction has been lost. That is called lost update problem. Now the next problem is called inconsistent read problem. Okay, you assume that we have two transactions. This is transaction 1 and this is transaction 2. I told you in a concurrent execution of the transaction, any of the operation will be collided with any of the operation. Okay, so let's assume that there is a read operation and there is an update operation. After that there is a read operation, and this read operation, and then this update operation, and then read operation, and then write operation, and then read operation, and then update, and then write, and then this update, and then write. So anything could be possible. So any operation can collide with any of the other operation in concurrent execution. Okay, let's see one scenario where we have the inconsistent read problem. Now this is the scenario where some of the transaction of T1 is executing, then some of the transaction of T2 is executing, then some of the transaction of T1 is executing, then some of the transaction of T2 is executing. Now let's see, this is my original database where the value of A is 5,000, value of B is 8,000, and value of S is 0. Correct? Now let's start the execution. Now first there is a read operation on A. So what it will read? It will read 5,000, right? There is a 5,000, so it will read 5,000. Okay, now 5,000 has been read. Now the A will be updated with minus 10,000, minus 2,000. It means this 5,000 will be minus 2,000, means it will be 3,000. How much it will be? 3,000. Now again there is a read operation. So what it will read? It will read from the database only, because we haven't done updation into the database. So read will be always done by the database. So read. So what it will read? It will read 5,000. Correct? Now here, what is the scenario? The scenario is whatever changes T1 is doing, it should be reflected here. And then this read will be read by the updated value, but it is not reading the updated value. It is reading the old value. And what is a new value? This is the new value. This new value is not reflected here. And this transaction is reading the old value. Now read S, it is okay. Read S means 0. It is reading 0. It is okay because it is not the old value. It is the recent value. Now S will be updated as equal to S plus A, but S value supposed to be added with the new value, but it is added with the old value. So now S value is 5,000. Then there is a write operation. Then this value will be changed. The A value will be changed as 3,000. Then there is a read operation of B. So 8,000 will be read. There is no issue on that. Then B will be updated with 2000 addition on that. So it will be 10,000, and then write on B will be done. There is a 10,000. Now what it is going to read? It is going to read the correct value of B. Why? Because the write operation will be done. See, it is reading the correct value of B. So this value has been changed to 10,000 because of this write operation, and this value has been changed, but after this 5,000 to 3,000 here. So this read is inconsistent read. This read is not a inconsistent. This is consistent read. Getting it? So I think you got the point. What is inconsistent read and what is consistent read? Inconsistent read means if some transaction which is executing earlier, if it is doing modification, then other transaction should get the modified data. But here it is not getting the modified data. That is a problem. This is called inconsistent read problem. Now come to the dirty read problem. In the dirty read problem, what happened? That some transaction T1 has done some write operation, but after that it fails and roll back. Just before that, some other transaction has read the value. So let's say the value of R is 1000. After the after the write operation, it should be 2000, right? So it has become 2000. But just after that, it will do the read operation. So what it will read? It will read 2000. And then there is a rollback. Rollback means again R value will be changed to 1000. But has already read 2000. That is called dirty read. Dirty read problem. That type of problem is called dirty read. So the concurrent accessing of database is creating the problem with the transactions.